Okay, so we are now in section 3 of chapter 9. So the conic section under study is the parabola. So section 3, chapter 9, just me and my calc babies, PreCalc babies here to study the parabola. So what do we know about parabolas, right? So if we had to think back to our pre-calculus, algebra 1, algebra 2, I mean, we know some things about parabolas, right? So, for example, if you think back to some of the forms that equations that you've seen before, that when you graphed took the form of a parabola. So maybe say y equals ax squared plus bx plus c, right? So that's a type of parabola that you've seen before. You may have seen it in a different form, written as y equals a times x minus h squared plus k. Now both forms are useful depending on what your question is, right? So the latter form is really nice if all you're interested in is finding, say, the vertex. And the former is really nice if you're trying to find y points or things of this nature, right? So what else? What else can we bring into this lecture? So, well, if you recall, and I'm just going to highlight this value of a. So if you recall the graphs of the parabolas that we've seen in previous classes, either opened upward or opened downward, right? And what determined whether it opened upward or opened downward was the sign of that coefficient a that's attached to x squared, right? So when a was positive, you had a nice parabola that opened upward, and when a was negative, you had a parabola that opened downward. So other useful information. So now the vertex was, well, there was two different, depending on which of the two forms you were given, the vertex of a parabola was located at hk. Now, if you were given the equation in the ax squared plus bx plus c form, another way for you to have found to find the vertex, right? And by vertex we mean these little dots that I'm putting here. Another way you could have thought about it as, or may have seen it as, negative b over 2a. That would give you the x value of that vertex. And then if you plug whatever that x value in is, so f of negative b over 2a, that would give you the y value, right? And last, let me say that for all the parabolas that we've dealt with, that I would assume that you've dealt with so far, opening upward or downward, you would make statements like, this is the minimum or the maximum. Okay, so what we want is a more robust definition of a parabola, right? We want a parabola that's not limited to opening upwards, opening downwards. What about if we want to open rightward or leftward, right? So we want a more robust definition of a parabola. And I'm now going to read the actual definition of a parabola. So a parabola is the set of all points in a plane that are equidistant, right? This right here, equidistant, meaning equally distant from a fixed line and a fixed point. Okay. So I'm going to give that line, fixed line, a name. We call that the directrix. And of course, the fixed point is the focus. Right? So what is a parabola? It's the set of all points in a plane that are equally distant from a fixed line and a fixed point that is not on the fixed line. I'll make sense of that in just a second. So let's continue. So first things first, let's go ahead and establish some information here. So if you look at the picture, I've placed some point Q, right? This point Q for sure is on our parabola. Now, if you recall, the definition on that previous page said the set of all points that are equally distant from a fixed point in a fixed line. Now, what I want you to understand is that no matter, I'm going to try to move, by the way, this might not work. I'm going to try to move this down a little bit. Yeah, that now my point is where I want it to be. So, all right, ready? Things are bugging me, so you're going to have to just entertain yourself for just a second. This is my point Q, which is located at some point XY. Okay, ready? So I need to understand what they mean by equally distant. Look, I got to get rid of this blue point. This is supposed to be the origin. All right. So equally distant from a fixed point and a fixed line. So listen, so this is the way you start, okay? Just like you don't start by drawing the circle and then defining the circle, right? You would start with a point, and then you would say, all right, anything that is, say, 5 units from this point is on our circle. Or anything that is 3 units from this point is on our circle. The same thing here. The way, if you're going to define a parabola, you would start with a point, right? So this is our focus. This is point P. And in this case, you're going to start with a point and a line, right? And now notice that clearly there is a distance from this focal point to this point on the parabola. And when we say equally distant, so I'm now going to draw a line from that point Q to this directrix. Okay, now what is somewhat clumsy in that definition is we should say parallel to the axis of symmetry, right? That is a little bit clumsy in that definition. But nevertheless, here we are. So the distance, let me go back now that you have this picture in mind. Let me go back a page. So the parabola is the set of all points in the plane that are equally distant from a fixed line and a fixed point. Equally distant from a fixed line and a fixed point. So, all right, now what you're starting to do is you're gonna start to see that the distance d sub 1 is going to be equal to d sub 2, right? So can you imagine that this point Q is some particle and it's just traveling along this parabola? So as it moves, I'm with you that the distances are going to change. D sub 1 and D sub 2 changes, but they remain equally distant to each other. So they're always equal to each other. That's what we mean by the definition of a parabola. Now, what I want to do is I want to make sure we understand this vocabulary a little bit more. So, right, so the focus, I'm going to erase this P. I'm going to erase this negative P. Let's get a little bit more specific here. So the focus right now is a fixed point and I'm going to say a distance, now right now I'm saying distance from the vertex. Ready? So, a fixed point with a distance of P to the vertex. But what's the vertex? So I'm going to skip a definition, go down. So the vertex, now, of course, you could always say the minimum or maximum. That's if your parabola is open up or down. But what this blue dot here, this vertex, is, and let me go ahead and define, I don't want to say min or max, right? Because that doesn't make any sense when the parabola opens right or left, right? We wouldn't say that that's the minimum or maximum. So the real way to think about the vertex is it's the midway or midpoint between what? Between the focus and directrix. Okay, but now what the heck is a directrix? So first off, let's notice that this dotted line is our directrix in this problem, and that's important to know. It is a line. It's not a directrix is not a point. It's a line. So a line. All right. Now I'm going to go ahead and say a line that is perpendicular to the axis of symmetry. I realize that each of these definitions requires calls upon a word that I haven't defined, so there may have been a better order to do them in. A line, well, let me say a line of distance negative P from vertex. All right, have I lost you yet? Ready? Look, if you stand at that blue dot, if you go a distance of P, wouldn't you be at the focal point? All right, if you go back to the blue dot, if you go a distance of negative P, wouldn't you be at the directrix? Okay, so it is a line of distance negative P from the vertex. And now I will say perpendicular, and this little symbol right here means perpendicular to what? To what we're going to call the axis of symmetry. All right, now what is this axis of symmetry that I'm referring to? So now all parabolas have this property, this symmetry about them, right? Where you can run a line that will through the vertex that will perfectly symmetrically divide the parabola into two, right? You could fold it over that dotted line, and that is what I'm referring to when I say the axis of symmetry. Maybe I'll see if I can touch that loose definition up a little bit. So let's see if how about, let's see here. Well, first off, bear with me for just a second. I'm going to see if there's anything else I want to really hit on before I do anything else. So how about we say the axis of symmetry runs perpendicular to the directrix through what? Through the vertex and the focus. Now, I kind of clumsily did these definitions out of order and in hopes that I would be able to make more sense of it. But remember, if you kind of go back to the way we do mathematics is we start with this idea that if you have a point, which we call the focus, and a line, which we call the directrix, and we define that all the parabola is the set of all the points that are equally distant from that, then what we would say is everything else is defined from this focus and this directrix. So I think you got the gist of everything that I need to tell you. Just the most important thing is probably that the directrix is a line. So in this case, the directrix, now I know that it runs through the point negative p. That is true, what I said, that it's a distance of negative p. But this is a line, so the graph of this particular directrix is x equals negative p. Right? It's a vertical line that runs through the that point negative p. Now, all of this so that we could get to a more robust definition of a parabola. And now look at what this does for us. So now we have a much cleaner formula for a parabola. Right? No more ax squared plus bx plus c type. I mean, we can set it up that way, but we have a much cleaner definition of a parabola. So let's start. Notice that when it says a horizontal parabola, I think I'm going to give myself a little bit of space here. So when it says a horizontal parabola, that means horizontal, meaning it's opening like this or like this. Well, it's y squared, defined as y squared is equal to 4 times p times x. All right, now, or a vertical parabola, now vertical meaning it's opening upward or opening downward, it's x squared equals 4 times p times y. So here's the hint, right? Here's the, if your x is the one that's squared, then it's the regular parabolas that you have been doing since algebra class. If you now have a y variable that is squared, then you have these new, potentially new parabolas that are opening to the left or to the right. So notice that both definitions, both equations have this value of p in them, right? And so this value of p. And, well, what is p? Remember, p, stay with me, p is the distance, right? So see this little dotted line I'm doing, the distance from the vertex to the focal point, right? The focus. That is the value of p that we're talking about. So, but now let's think back. Remember, sometimes in algebra class, sometimes the parabolas opened up, sometimes they open down. That would depend if it's a negative a or a positive a. So how do I know if it's opening left, right, up, down? Well, here we go. If the value of p, okay, is greater than 0, okay, so that's meaning it's a positive number. If the p value in that equation is a positive number, then the graph is going to open upward or rightward. Okay? Now, if the value of p is a negative number, right, p is less than 0, then the graph is going to open downward or leftward. All right, you got it. So you got it. So let's jump in and let's see if we can put some of these equations to work here. Ready? So let's see if we can answer this question. So we're asked to find the standard equation of the ellipse, what the heck, of the parabola. Let me erase that. of the parabola when the focus is at the point 5, 0, and the directrix is at the point x equals -5. Okay, so we want the equation. Now, again, if you would just heed my advice and look at some geometry, sometimes it really pays off. So ready? I'm going to go ahead and plot the point 5, 0. So over 5. 1, 2, 3, 4. So that's right here. And then I'm going to plot the line x equals -5. So that's a vertical line. All right, so there, right now you have your directrix. That's your P. And your, your focus, that's your P, and your directrix, which is your -P. Right? That's why you see 5 and -5. Okay. So what you want to do right now is you want to ask yourself, where is your focus located? Because remember, your graph is always going to open towards your focus, right? Like, ready? Let's go back to elementary school. Like it's like a little alligator, and or a Pac-Man. It's going to eat that dot. Some of you are too young to know what I'm talking about. So it's going to open towards the focus, right? Opens toward focus. So I'm looking right now. I see that my focus is at the point 5, 0. I don't know anything about this. I don't have to know anything about this graph to know that it's going to. But I don't have to know anything more, I should say, without being able to make the statement that it's going to open towards the focus. Okay, so now with that in mind, I know that this is what? This is a horizontal parabola, right? In other words, the y is the one that's squared. So y is equal to 4 times p times x. Okay, so where did that come from? That from the previous page. That's the new formula for parabolas, horizontal parabolas. And we're almost done. All I need to know, all I got to do is plug something in here for p, right? All I got to do is plug something in for p, and then we're all done with this problem. So what is p in this scenario? Well, you should have guessed it. It's the distance. It's the distance from the vertex to the focus, right? Don't you agree with me that we went 5 to the right? So in this case, p is equal to 5. And that's all I got to do is plug in 5, and we're all done. So y squared is equal to 4 times 5 times x. Or in other words, y squared is equal to 20x. That is the equation of this parabola. All right, nice. So let's see what else we can do. So now we're given an equation, and I'm assuming they're going to ask us to find some points, right? Or some other information about the parabola from the equation. So it says find the focus and the directrix of this parabola. Okay. So obviously the focus should be a point, right? So I want to, and the directrix is a line. This is important. You have to tell me what line runs, what the equation of the line for the directrix. All right, now let's look at a little bit closer at this equation. So this is a y squared equation, right? So the generic form of this is y squared is equal to 4 times p times x, right? But what we have is a 12 instead of a 4p. But that's good because that's going to help us, right? So that means 4p is equal to 12. Therefore, P is equal to 3. Right? So now that I know that P is equal to 3, but hold on for a second. So I'm going to start at the origin. I'm going to start at the center, or I should say the vertex in this case. And I am going to go a distance of 3, but am I going up or right? Well, think about this as a horizontal parabola, because the y is squared. So I need to, when I move 3, I need to move 3 to the right. So this is P. Right now, of course, here is the vertex. All right, and let's go ahead and answer this question, though. It says, what is the focus? Well, the focus is the point, or the distance P, so that is 3, 0. So that's what I want to write, 3, 0. All right, now, what about the directrix? Okay, so let's get back to the vertex. And now we want to move -3. So 1, 2, so here. All right, so here's it, we're at -3. But I don't need that. I don't need a point. I need a line. I need a line that goes through that that point. So first off, of course, as I've already mentioned, parabolas are always going to open towards the focus. So I know that my graph looks like this. And let me go ahead and, so that would mean that my directrix, which is always perpendicular to the axis of symmetry. So my directrix is going to look like this. And I hope you guessed it. I just need to know whatever equation that is that graphs that vertical line, and that's just the equation x equals -3. Now, part B is to graph it, and so I'm going to erase this little graph here. And let me now start from here. So can you and I agree that in actuality, all we have is one point on this parabola, right? I mean, the only point that I have the focus, yes, I have the directrix, but the only actual point that I have on the graph itself is the vertex. So I don't know how you're going to graph with one point, right? But let me show you a trick if you want to graph a parabola very easily and get a very good graph. So let's go ahead and make clear that I have y squared is equal to 12x. So if I wanted to, I could just start picking x points, plug them in, and get y points, right? You should get 2 y's for every x that you input, except at 0. But, and then you can, well, kind of like what your calculator would do, it would just create a series of 100 different little tiny dots and then connect them for you, or and then that would be the graph on your screen. But if you wanted to get a good graph by hand, and you didn't want to go through picking you don't want to have, let's say, 10 or 20 different dots to connect. You want to make life easy on yourself. So here's what I'm going to tell you right now. There is an x value that you can choose. Okay, one x value that you can choose that will really make will make a lot of headway in graphing this, right? And that x value is going to be what? Well, it's going to be P. So, in other words, the focus. So if I plug, now of course, in our case, it's in this particular case, P was equal to 3. but that is what I'm going to plug in. So I'm really going to be plugging in 3 for x. Ready? So that leaves me with y squared is equal to 12 times p. In this case, p is equal to 3. That means y squared is equal to 36. Therefore, y is equal to plus or minus 6. So I don't know if I have 6 places to move here. 1, 2, 3, 4, 5, 6. So if I travel up 6 and I travel down 6, then now this is a really clean parabola. Now I still can't draw it very well, obviously, but I hope that that makes sense. So anyway, so we would go up 6, down 6. That would give me 2 more points in addition to the vertex. And if I could draw, you would see a nice clean parabola. Those are 2 very good points to choose. And I'll go ahead and tell you right now, there is a name for this. So if you were to draw, let's just say a chord that runs through that point P. We call this a focal chord. It's a segment. And the technical name for that focal chord is the latus rectum. That is the actual name for that chord. All right, almost done. Let's actually see this in practice. So, if you ever have some time on your hands, and let's say you have, I don't know, some type of flashlight at your house. Maybe it's broken, maybe not. But take it apart, and you'll see something that's pretty cool. So the idea of, let's say, so this is a flashlight, right? So you have your shining light in this direction. Now, if you were to take the head off this flashlight, what you would notice, well, first you would notice some type of reflective, actually, no, my sincere apologies. I drew the light going the wrong way. I'm looking at it upside down. So we're going to be shining light this way. So if you were to take this the cap off your flashlight and you were to just study it for a second, you would notice that you have some type of light source, some type of LED, and then you would notice that there's probably some type of reflective, maybe a mirror or maybe some type of reflective material. And what's interesting about the properties of a parabola is that when they place this light source, some type of light source, they place that light source exactly at the focal point in order to maximize the amount of illumination that comes out of that light bulb, right? Because what happens is there's certain reflective properties of these parabolas. You can see it on your headlights too. If you took your headlights off your car, and there's certain reflective properties where it's bouncing off of this reflective surface in this heading towards the where you're shining your light to. And my oldest son and I, Sebastian and I, at one point in time we were trying to build a flashlight, right? And we took a piece of reflective material and kind of bent it into the shape of a parabola, and then of course we had this little LED that we were going to use as this light source, and I was interested in trying to find the equation of how we bent that reflective source. Now my son was more interested in shining this flashlight in his brother's eyes. He wasn't quite interested in the math behind here, but if you take what I'm trying to tell you, if you move that LED from the focal point, you will get less light, right? If you move that to the right, if you move it to the left, you move it up, move it down. In fact, a lot of flashlights allow you to adjust the illumination, right? You can adjust the illumination, and that's really what's happening there. Now, with all that in mind, all that, you don't even have to pay me for all this extra knowledge bombs that I just drop on you. But now let me see if we can put this to use, right? So it says this following example says so an engineer is designing a flashlight, right? Using a parabolic reflecting mirror and a light source. So as shown. So here is the engineer's design. Now it says the casting, right? The casting has a diameter of 4 inches, right? So 4 inches, as you can see from the picture, and a depth of 2 inches. All right, here we go. So there's 2 parts to this question. The first part is, part A is, what's the equation of the parabola? Right? And then part B of this problem wants to know where to put the focal point. Right? So what's the location of the focal point? All right. So as I said in a previous, probably a previous video, is I really wish we could spend a lot of time modeling. So let's take this word problem and put it into a picture within a rectangular coordinate system, right? Because once the beauty of this Cartesian coordinate system is that you blend your algebra and your geometry, so you can actually get equations that you can from your geometry. So ready? Let's make life easy on us. Let's assume that the vertex is at the origin. And now let's see if we can take the dimensions of our flashlight. Look, so it says its base or its casting is 4 inches and a diameter of 4 inches. So that would mean I would want to go 2 to the right, and I would want to go 2 to the left. Well, I would want to, but I didn't. 1, 2 to the left. All right, and now it has a depth of 2 inches, so I'm definitely going up 2. And I would be going up to here. So in other words, this point right here would be 2, 2. And this point right here would be negative 2, 2. All right, so let's go ahead and draw the parabola. So the parabola is going to look something like this. All right. So at this stage, we want to form an equation. Now, the way I drew it, are you with me that it's opening upward? So this is definitely going to be an x squared equation. And formally the equation for these parabolas opening upward would be x squared is equal to 4py. All right. So now the real question becomes, what is the value of p? Okay. So let's think about it. how could you figure out the value of P? Well, let me phrase it this way. Right now, this equation has three unknowns. I don't know X, I don't know P, I don't know Y. But if I knew two of the three, are you with me, that I could find the third? So let's actually do that right now. Let's see if we can, is there any information that would give me two of those three unknowns? Well, all I need is a point on the parabola. If I have a point on the parabola, then I have the X and the Y value, right? Now, not the vertex, right? Not 0, 0. That's not going to help me. So are you with me that at this point right here, we'll call this point Q. This is definitely on the parabola. So X is 2, Y is 2. So look, I'm going to use that point, 2, 2. So I'm going to plug 2 in for the X, and I'm going to plug 2 in for the Y, and I'm going to solve for P, right? So let's do that. So I have 2 squared is equal to 4 times P times 2. So that means 4 is equal to 8. 4 times 2 is 8. P, that means that P is equal to 1/2. Now, I needed that. I needed that 1/2 so that I could plug in to my equation. And then I have the actual equation of that parabola. So the actual equation is x squared is equal to 4 times P, right, 1/2, times Y. So x squared is equal to 2y. There it is. That's the equation of your parabola for this flashlight. Now, the part B was, where should you put the focus? And I just got done explaining to you that you want the focus, or it says, where should you put the LED, the light source? And so, I just got done explaining to you that you're going to want your light source to be located at your focus, right? That is how you will get the maximum amount of illumination. Ready? So all I need to answer this question is, what the heck is the focus? Where should the focus be? Well, obviously, the focus is going to be at 0 P, right? But what is P in this case? So the focus is at 0, 1/2. P is equal to 1/2. And now I'm going to do that. So here we go. So if I go up 1/2, right there is where, that's your focus, that's your light source. Right? That is where you should put that LED or whatever else it is that you're shining. And then when you do, it's going to bounce off that reflective substance, and you'll get your nice, beautiful flashlight. I will see you soon.